All right, so we are going to finish up our discussion on functions. So you can see this table, different ways to represent it. So the first is in a table. So if you're looking at a table and you're trying to show whether or not it is a function or not, sorry, I thought I had this open in Notability, but I don't. So you're trying to determine if a table is a function, then you want to make sure you don't have any repeating y values. So notice here that none of these are the same, okay? So if you want to make a little note, in order to be a function, if you're looking at a table, no repeat numbers in the y column. Then we had a mapping. So the mapping shows you your domain and your range. Remember that your domain is your set of x values and your range is your set of y values. And then your mapping takes every x coordinate and points an arrow to where it belongs on the y. So if you're looking at a mapping diagram, if you want to figure out whether or not it is a function or not, no double arrows coming from an element in the domain. Meaning, when I'm looking here, -2 only has one arrow, 0, one arrow, 2, one arrow. If I have two arrows coming out of something in my domain, mapping to the two different numbers in the range, not a function. So you're always looking to make sure each element in the domain has only one arrow coming out of it. Otherwise, you're mapping to two values. To be in an equation, we did not talk about how to look at this and determine if it is a function. We're not going to talk about that right now. But if you want to maybe think about some examples for what that may look like, but we're not going to talk too much about that. You want to be comfortable with looking at a table, looking at your mapping diagram, and then also looking at your graph. So how do you determine from a graph? You want to make sure you're using the vertical line test. So the vertical line test means if I drop a vertical line all the way through my graph, it's only going to hit it once. So that's your review of how to figure out something as a function looking at different notations. Down here, we're talking about function notation. This is what we talked about yesterday in the Desmos activities. Function notation really is no different than just a regular equation. It's just a really fancy way of writing something. So the difference is that I'm taking, instead of y, I'm replacing it with f of x. That's how you read that, f of x. And again, it's really just a different way of writing it. It means exactly the same thing. It's a little bit more specific because it's telling me that x is my input. So whatever number I plug in for x, I'm going to spit it out, do all of this crazy math work inside of the function, and it's going to spit out my final answer over here. Okay? But when we're talking about notation, it's just an equation. It's just a fancy way of writing y equals 3x minus 8. But now I'm just changing how I'm writing it and saying f of x is equal to 3x minus 8. Just a different fancy way of writing an equation. If we want to specify the parts, this is always your input, and then it's going to output this rule. So we looked at those graphs yesterday. If, for example, I wanted to know using this rule, well, what is the function at 2? That means in this notation, what's my function at 2? That means take 2, plug it in everywhere you see an x, and you're going to simplify it. So my function at 2 means do 3 times 2 minus 8. 3 times 2 is 6. 6 minus 8 is -2. So when I plug 2 into my function or my equation, it gives me an output value of -2. So that means my coordinate point would be 2, -2. If I were to graph this, I have 1, 2, 3, 1, 2, 3, I would be at 2, -2. Okay? It's just a really fancy way. The only real benefit to using function notation other than an equation is that in this step here, you can see what you're plugging in. So I can see I'm plugging in a 2.